Assalamu alaikum students. Today we will start with a paper 4 of October number 2025, second variant. We will move on to the question number 2, part D. An oxidizing agent converts iron 2 plus ions to iron 3 plus ions. Define the term oxidizing agent. So we remember an oxidizing agent is that species which is itself reduced and oxidizes the other substance. Something which is itself reduced but it oxidizes the other substance is called the oxidizing agent. So we will write here substance which oxidizes other and itself reduced. You do not need to mention how that happens because they are not asking about the way of oxidation or the way of reduction. Then, next part, explain why conversion of iron 2 plus ions to iron 3 plus ions is described as oxidation. So here we will see the conversion is from iron 2 plus to iron 3 plus. It means there was initially 2 electron lost from iron 2 plus, and in iron 3 plus there were 3 electrons lost. The loss of 2 electrons versus loss of 3 electrons, we can easily compare. There is an additional 1 more electron lost. Additional 1 electron lost when it converted from iron 2 plus to iron 3 plus. So as a result of this, we can simply say it is the loss of 1 electron. Loss of 1 electron. You can either represent electron with E minus sign or you can write the full name. The preferred way is to write the full name. Then third part, the oxidizing agent for the conversion of iron 2 plus ions to iron 3 plus ions is aqueous potassium manganate. State one condition needed for the oxidation to take place. All right. So converting iron 2 plus ion to iron 3 plus ions in the presence of the uh, in the presence of the strong oxidizing agent is not a complete requirement. Also need the acidic medium because we studied this in the literature. The reaction only occurs in acidified aqueous potassium manganate. Acidified aqueous potassium manganate. That's the whole condition and the name of the reagent required for the oxidation. So we will say acidic condition. Acidic condition is required. Then E part, iodide ions reduce iron 3 ions to iron 2 plus ions in aqueous solution suggest the identity of the other product formed in this reaction. So if we see iron 3 plus ion is getting reduced to iron 2 plus ion, that's about one element. We can consider a reaction is occurring between iron 3 plus ion, which is one reactant, because you just have to pick up the words. The statement says iodide ions reduce iron 3 plus ions, which means these two are reacting with each other. These two are the reactants. That's for the first reactant, and this is the second reactant, iron 2 plus. and iron 3 plus is the second reactant, and iron 2 plus is the one product. We are supposed to tell the other product, that is what we do, let's suppose. So we write the equation iron 3 plus react with the iodide ion, and then the product form will definitely one of the product is already mentioned, which is iron 2 plus ion. We need to understand what could be the other product. It is clearly it is clearly shown here. The other element is iodide, which means the other product will definitely a product of the iodine. It will be something made up of the iodine. So I just write I here for an instance, and then look for the formula of that iodine. Here you remember the iodine is getting oxidized. It is being oxidized. If it is being oxidized, which means getting oxidation, then definitely iodide will be reduced. That's a simple logic. It is the opposite of the oxidation. But how does the element must be represented if it is reduced? We are considering iodine here, and iodine belongs to group 7. In group 7, we have fluorine, chlorine, bromine, and then iodine. If you are going to represent the element of the group 7, you must represent that element in the form of the diatomic molecule because they only exist in the form of the diatomic molecule. So for this reason, I will represent I2 here. It can only be I2, it cannot be I3, it cannot be simply I, it cannot be I4. That's totally wrong because group 7 elements are only represented as I2. And if it is I2, we know it is the elemental form. The elemental form has the oxidation number of 0. It has 0 charge on it or 0 oxidation state. So we can clearly see -1 is changing into 0. And it is basically the iodide is being one more thing oxidized. I, iron 3 plus was reduced to iron 2 plus. The decrease in the oxidation state from +3 to +2 is reduction. Then I2 is showing the oxidation from -1 to 0. It shows oxidation. For iron, it is from -1 to 0. This is oxidation. In this way, we have completed the Q&A. Now, question number 3. A student prepares a sample of the insoluble barium sulfate. The student adds aqueous sodium sulfate to aqueous barium chloride. The student carries out the following steps. Dissolve 0.1 mole of barium chloride in 100 cm distilled water. Add an aqueous solution containing 0.1 moles sodium sulfate to the beaker containing barium chloride. From step 1, stir the mixture, filter it, dry the solid, and filter the vapor. Complete the simple equation. So the reaction is given barium chloride plus sodium sulfate to produce barium sulfate. It is simply the displacement reaction in which two salts, this is salt, this one is also a salt, both of these are salt. So in this way, we can say that if two salts are reacting with each other, they will also produce another salt here. And barium sulfate is basically a solid form of the compound. Barium chloride, aqueous, and sodium sulfide. We remember it produces the white PPT. It produces the white PPT. So it will be in the solid form, and then the other product will definitely be the union of these two, Na and Cl. These two will be combining with each other, and it will produce NaCl. So NaCl can either be aqueous form or it could be the aqueous form or it could be the solid form. Both can be acceptable. You need to represent the state symbols in these smaller brackets. You can either write solid or you can write the aqueous form. But barium sulfide will definitely be the solid form. It cannot be the aqueous because it does not dissolve. Then B part, calculate the mass of barium chloride dissolved in step 1. So how much mass of the barium chloride is used? We need to calculate the mass. This is basically the stoichiometric part of the question. In the step 1, 0.1 mole is used. Barium chloride has this much mole. It is simply converting the mole into the mass, and we remember the formula which we used multiple times. Number of moles is equal to mass over mr. So we can rearrange this equation. Mass is equal to number of moles into mr. The moles is about 0.1 mole, and about the mass of the barium chloride. For this purpose, you need a periodic table. So in the periodic table, the mass of barium is 137. So we go back to the question. 137 for barium plus chlorine mass is 35.5, and there are two atoms. So it is time to, you will get a mass equivalent to 208. So this is equal to 208. Multiply this 208 with 0.1. So the answer is equal to 20.8 gram. So 20.8 gram is used. If it is clear, that's fine. If not, you can let me know. And then C part, the concentration of sodium sulfide aqueous in step 2 is 1.25 moles per dm3. Calculate the volume in cm3 of 1.25 mol per dm3 sodium sulfate added in step 2, which contains 0.1 moles of sodium sulfate. Okay, so here the concentration is given and we are supposed to find the volume. Concentration versus volume, you remember the formula, N is equal to C into V. And from here we can tell V will be equal to N over C. The moles are equivalent to how much? We have the mole given here, 1.25. The concentration is 1.25. Now, how much of the mole is there? How much of the mole is used here? For this purpose, we would go back to the question and see 0.1 mole of the sodium sulfate was added into the solution in step 2, and this is the same value here, 0.1 mole of the sodium sulfate. So simply put here 0.1 divided by 1.25. And one more thing, the answer must be given in centimeter cube. So you are basically using the value coming from the concentration which is having dm cube in it, but your answer must be in centimeter cube, which means the answer which you'll be getting must be multiplied with 1000. Since answer would be in decimeter cube, and if you convert it, you will be getting 0.08 dm cube. Now multiply this value with 1000, it will be equal to 80 centimeter cube. If it is clear, please raise your hand, students. If it is clear, please raise your hands. Okay. Then D part, the state and color of the solid form is step 2. In step 2, we are forming the sodium sulfate reaction with the barium chloride, and this is already shown here, barium sulfate. This is the product in step 2, and we said that the color is white PPT, so it will be white. The mixture is filtered in step 3. Here is the general term given to solid left in the filter paper after filtration. So you remember filtration when done in the conical funnel has the filter paper inside. Another thing which is left behind over here is termed as the residue. And those which is collected from the filter paper, that's called filtrate. This is filtrate and this is the residue. So if we say to a solid left in the filter paper that's inside of the flask funnel. So it is residue. F part, the actual mass of dry barium sulfate collection step 4 is greater than the expected mass. This is because the student should do an additional step between step 3 and step 4. Suggest what the student should do in this additional step and explain why the actual mass collected is greater than the expected mass. So in step 4 and step 3, we remember uh, barium sulfate was formed in step 2, and then that barium sulfate treat the mixture and then filter it. Where is the filtration here? Where did we filter the mixture? We filtered over here. Mixture was these two were stirred. Barium chloride and sodium sulfate were stirred over here and then filtered it. And after the filtration, it just said dry the solid left in the filter paper where is no kind of the evaporation of the liquid present in the filtrate. So that is where we would say that the evaporation must be done, and we must also getting barium sulfate in the form of the solid, so that solid must be rinsed with water. Barium sulfate is already a precipitate form, so it must be rinsed with water. Along with that, we have to also explain why there could be the higher mass produced. If we look back in the equation, we remember that in the equation there was the sodium chloride form. So we can say that the sodium chloride could also be the reason for an additional amount of the mass or for high value of the mass because it is already in the aqueous form. So the aqueous form can easily penetrate through the filter paper. We were supposed to get the residue, but the sodium chloride can also penetrate through the filter, but they can be a consequence that they are stick together. NaCl, NaCl could stick to the barium chloride during the filtration. So for this reason, we can consider some amount of the sodium chloride is also present in the calculated mass. So in 3F, we will write rinse the precipitate, rinse the precipitate or the residue that is containing the barium sulfate. The actual mass of dry barium sulfate is spectroscopically greater than the, so we are supposed to rinse it, and the higher mass or greater mass is due to NaCl present in dry sample. So a dry sample can also contain the uh, NaCl. So that's why there could be higher value. You must think critically for such type of a question, because not everything is properly outlined in the statement. You have to think critically, and that's where not all the students get full marks. And that's where the few selected ones get all the marks. G part, state the name of this method of salt preparation. If we remember, we had discussed three methods: the excess method including the excess amount of the metal carbonate, and excess amount of the base. Then the second method was the filtration, in which there were soluble bases and salts. And the third one was precipitation, which is this one. So this is the precipitation because the salt produced is already in the solid form. Solid salt, solid insoluble salt, to be more specific. Solid insoluble salt is produced. The next part, barium salt can be used in place of barium chloride. State the name of a different barium salt that can be used in place of the barium chloride. So we need a kind of a salt which must be soluble, because in the equation we can see barium chloride is aqueous form. We cannot have any other salt that may be of insoluble type. We must have only the soluble type of the salt. So what comes in your mind? It should be, we remember from the literature that all nitrates are soluble. All nitrates are soluble, which means we can consider barium nitrate. And what should be the formula? Barium nitrate formula must be remembered. We remember the formula of nitrate is NO3 minus 1, whereas a charge in the barium is plus 2. So if you combine together, you will get the formula BaNO3 whole twice. So this will be the formula here. We can have barium nitrate, then salt of the sulfate type. So it can be the simply same element of group 1, potassium. You can have the potassium. Okay, one more thing. They are asking you to write the name. Yeah, one more important part. They are asking you to write the name. So do not write the formula, because that will make your answer incorrect. So for the first part, you will write barium nitrate. And second point, you will write potassium nitrate. And then the third part, aerosol can be made by this method. So if you are making the barium salt, that must be in the solids and insoluble, solid insoluble. One of them was the barium sulfate. This was insoluble. What could be the other type of the salt that can be insoluble? We remember from the literature of the salts that uh, among the carbonates, only the group 1 carbonates were soluble. Then in the ammonium case, NH4 plus carbonate were also soluble. All the salts of sodium and potassium are soluble. Group 1 has more specifically sodium and potassium, more specifically. So all salts of sodium and potassium are soluble. Also, all salts of the ammonium are soluble. And among the carbonates, only these are soluble, which means barium carbonate is insoluble. BaCO3. So you can write the name barium carbonate. Barium carbonate is insoluble. Then the next part, question number 4. Nitric acid and sulfuric acid are strong acids. Ethanoic acid is a weak acid. Um, we do not have to go through, so that's not relevant to our topics yet. Okay, now in this one, this is this part, the oxidation number of O atoms in aluminum nitrate is -2. The formula of aluminum ion is in aluminum nitrate Al plus 3. Determine the oxidation number of nitrogen atoms in AlNO3 whole thrice. Show your working. We need to find the oxidation number of nitrogen. So we will just look at this formula and try to find the oxidation number in nitrogen. We see that NO3 and whole thrice must have a charge of -3 to balance with the aluminium, which already has a charge of +3. Aluminium has +3 charge and nitrate will overall have -3 charge, which means a charge on just one NO3 will be -1. These three are basically telling the overall charge -3. So a charge on just one NO3 is equal to -1. Now, if you remember, if you can easily understand, we can now try to find the value on the nitrogen. We have -2 for one oxygen atom. So for three oxygen atoms, it will be -6. Now to balance it with -1, we must have +5 on the nitrogen. So +5 is the oxygen number of nitrogen. Question 5 to be skipped. Question 6 to be skipped. And that's it. They were just these questions relevant to the topics which we are currently covering, and you can see there is no question related to the energetics, no question related to the uh, what we know about the equilibria. So that's all we have to attempt. So till this point, do you have any question? Please let me know. All right, fine. So we'll cover the next paper in our next class, and by that time, keep practicing the other papers. So, Shal, can you tell me how many papers you have attempted by yourself?